Welcome everyone. In this video lecture, we will solve a very fundamental GATE 1999 question in which we have to find, or we can say we have to find the first dominant pole encountered in the frequency response of a compensated op-amp. So this one is a very basic question. So in this question, we have to know the open loop gain versus frequency curve of an op-amp. So first I am drawing the very basic open loop gain, that is in the y-axis, the gain curve, gain in dB, and in the x-axis frequency in hertz. So the frequency response, because if you know the frequency response, you can easily tell the answer of this question. So the frequency response is somehow look like a low pass structure, like that. Once again, I am just okay. This one is the structure and the value. So this value is around 2 into 10 to power 5. Okay, and this point is around 5 hertz. Okay, or better to write, we can write 5 hertz, then 10, 100. The we can say this scale is in the log scale, 10, 1k, then 10k, 100k, or 1 mega. Okay, so this one is the curve for a open loop gain versus frequency curve for IC LM741. So this one is the 2 into 10 to the 5 is the highest gain, and this should be our 10 to the power 5. We can write it 10 to the power 4. So this curve is very important. 10 to the power 3, 10 to the power 2, then 10 and 0, like this. So this one is the curve. So more ideally we can say this one is the curve. Okay, this kind of curve is the gain versus frequency. Okay, and this one is your 3 dB cutoff frequency, and this point is called your break frequency. So this one is the break frequency. So in our case, the break frequency is this one. Break frequency, or sometimes it is called the 3 dB cutoff frequency. Okay, so the break frequency is the 5 hertz. So our answer will be 5 hertz. Okay, so this one is the correct answer for this question. Okay, so this one is the correct answer, 5 hertz. So 5 hertz is the correct answer. In addition to that, in an op-amp IC, in case of LM741, as we know the gain bandwidth product, there is a very famous term, gain bandwidth product. So gain bandwidth product, as per the name says, gain and the corresponding frequency. So for this frequency, we can say the gain bandwidth product 2 into 10 to the power 5, the gain, and the corresponding break frequency it is 5 hertz. So this is 10 into 10 to the power 5, so 10 to the power 6. Means now this should be in 1 megahertz. So the gain bandwidth will be 1 megahertz in case of op-amp, and the break frequency, we have to remember, for an op-amp break frequency will be 5 hertz. Okay, and gain bandwidth product will be constant. Okay, for any other we can also find. So 5 hertz is the break frequency, and the frequency at which the gain is 3 dB down from its value at 0 hertz. Okay, so this one is the 3 dB, 3 dB cutoff frequency, or this one is the, we can say, the break frequency for this op amp. So this one is very important, break frequency, and the gain bandwidth product is constant. So this is the thing that we have to know. And this is the, what we can say, the curve, gain versus frequency curve of an op amp. So this is the important one. So mainly the manufacturers generally specify the gain bandwidth product in an case. So in a specification sheet, if we go for the a specification sheet of an op amp, if we go for the specification sheet, or we can better to say the data sheet, the manufacturer, I'm writing, manufacturer gives the curve between open loop gain, open loop gain versus frequency. Okay, and this one is a log scale, so that's why 5, 10 like that. So this one is the thing for this question. So this one is the very simple question, but we have to know what should be the break frequency, and the gain bandwidth product of an op amp is constant, which is 1 megahertz. So this is all about this question. So thank you for watching this video.